This presentation will analyze the work completed on the portal frame structure constructed, covering work completed on both Revit and SpaceGas. The parameters were set up by the client in the briefing and can be seen on screen now. These are the specifications in which we use to construct the portal frame structure that will be discussed in this presentation. Furthermore, the structural concrete slab was to be 400 mm thick and have a slab edge overhanging the edges of the structure's walls by 200 mm. It was also specified that the wall cladding be constructed of spandex and the roof sheeting constructed of Clip Block Classic 700. A minimum of 10 windows and 2 doors, one of which being a roller, was also to be added to the structure. A mezzanine was to be built 4 meters off the ground and cover a minimum area of 8 meters by 5 meters.
The LightSac Z and C's user guides are used to select the most appropriate size purlins and girts for the given design parameters. The Z sections used for the purlins are a Z20019, and the C sections used for the girts are a C20019. The spacing of the purlins and girts is assigned using the LightSac Clip-Lock Classic 700 and Spandeck design and installation guides, as these are the client's requested products. The spacing is also selected to ensure the most optimal combination of structural stability and hold-down capacity without causing significant increases in cost. Furthermore, the selected size and spacing of the Zs and Cs results in zero bracing requirements, which will lead to a more economic and sustainable design. All steel connections in the structure have a bolted cleat system and are designed to comply with Australian standards. After the architectural design was finalised, SpaceGas design software has been used to ensure member compliance with the relevant Australian standards.
Creating the portal frame structure in SpaceGas derives the necessary dead, live, and wind loads as parameters to determine the design serviceability and strength limit states. This derivation accounts for the material's dimensions and properties as well as the local wind region of Wollongong. The uniformity of spacing between frames allows these 3D loads to be simplified into a singular 2D load for further analysis. These loads are put into combination load cases to quantify the design limit states. For the serviceability limit state, we evaluate the dead load plus live load combination. For the strength limit state, we evaluate 4 combinations: 1.2 times the dead load plus 1.5 times the live load, 0.9 times the dead load plus the internal and external crosswinds, 0.9 times the dead load plus 0.7 times the internal crosswind, and lastly 0.9 times the dead load minus 0.65 times the internal longitudinal winds. These resulting limit states align with the appropriate Australian standards programmed into SpaceGas, ensuring the structural integrity of the proposed structure.
The non-structural elements of the brief have been designed with a keen focus on habitation and functionality. Large custom windows 2500 by 1500 are situated on all walls, pulling in the natural light, reducing the necessity of cost of artificial lighting. Further, due to the large footprint and potential industrial application, a dual roller door design has been adopted to cater to a more efficient entry-exit traffic flow within the building. These dual doors, in conjunction with the multiple large windows, will facilitate an increase in natural airflow throughout the structure, increasing the livability and a reduced demand for a large HVAC system. The requested 8x5 mezzanine is structurally independent from the larger portal frame, allowing for its relocation within any portion of the portal frame or its potential removal. We would like to thank the client for choosing to partner with us, and we look forward to our future endeavours.